This video I'm going to attempt an explanation of what hashing algorithms are and give some examples of what they are used for. Personally, I mostly use them for blockchain development, so the first thing I want to do is find out which algorithm I should be using for that, so I'll open up the Google and Microsoft AIs to ask which is the best. And they both respond with a similar explanation that the best algorithm really depends on the specific requirements and use case, but the first algorithm they mention is SHA256, which is what I currently use. So let's take a look at the code I wrote to help explain how that particular hashing algorithm works. You can see here in the Blazor C# code block, I start off with a couple of strings for regular text and a path to a file that contains the same text. So when the page initializes, what this code is going to do is use the text I defined in the string to run through the SHA256 algorithm and return the result in the first header. Now for the second header, it's going to check to make sure the path to the file exists, and then run the contents of the file through the same algorithm and return those results as well. So I'm going to open the file and you can see that it has the same value as the string does, so the hashing algorithm should return the same hash value for both. Now I'll go up and click on the Start Without Debugging icon, and hopefully this will demonstrate the best way for you to understand how hashes are generated. What you are seeing is two identical hashes for the word testing with a capital H. So if I go to the file again and change the text to testing1, then save the file and hit refresh on the browser, the bottom hash value will now be different. So the main idea behind these hashing algorithms are to take any amount of data and then convert them to a unique value that has a specific length. So for example, if I wanted to compare the contents of say a 1 GB file on multiple servers, hashing would be a really good way to do that, since I would only need to transfer the hash value across the internet instead of the 1 GB content. This is why hashing plays such a big part in most decentralized cryptocurrency projects. You can throw a bunch of transactions into a block and then chain them all together using hash values to quickly verify which chain is most agreed upon. So if most everyone is running the same code that will generate the same data, and a small number of people decide to alter any transactions in their chain, that would generate a different hash value and invalidate their activity on the network. For security purposes, a good hashing algorithm will only go one way, meaning it should be computationally infeasible to go backward from the hash value to the original input data. These algorithms should also be collision resistant, which means it should be very difficult to find two different inputs that produce the same hash value. While collisions are theoretically possible since you're mapping a potentially infinite set of inputs to a finite set of outputs, a good hashing algorithm minimizes this probability. SHA256 is the most common used now because someone has figured out a collision attack against SHA-1, which you can read all about by going to the website shattered.io. The site also has two different PDF files, so you can see for yourself that they will create the same hash even though they do not have the same content, so I will download both of the files to test with my own code. Reading about the attack will also help you better understand how hashing works, so it's worth the time if you're really interested. I want to see for myself if these files will generate the same hash using SHA-1 though, so I'm going to duplicate my demo file and rewrite the code so it hashes both files. I'm going to run the code using the SHA256 algorithm first so I can verify that it will generate a unique hash for each file. And it does, so I'll close the browser and then just find and replace SHA256 with SHA-1 to see if it will generate the same hash as they claim on the website. So now that my code is using the SHA-1 algorithm, I'll run it again and I get the same hash as they claim, so hopefully this helps you understand how hashing works a little more. You may have noticed that SHA-1 has a shorter hash value than SHA256, so I'll try to explain why that is the case next. The SHA-1 algorithm produces a 160-bit hash value, while SHA256 generates a 256-bit, and the bit length directly determines the length of the output. So you'll see here when I alter the code a bit to show the length of the hash value and then run it, I'll have a 64-character length for my hash value when using SHA256. Next, I'll write the code to use the SHA385 algorithm, and when I run that, you'll see that now my hash value length is 96 characters long. And when I use the SHA512 algorithm, I get a hash value that is 128 characters in length. Hopefully this video has helped, and feel free to ask any questions that you still may have in the comments. Thank you for watching, and please like and subscribe for more quick and on-point videos.